So now that we have picked our scale of measurement, the next thing we need to do is assess whether our measurement, our instrument, is actually a good measure. And the first step in doing that is measuring reliability. So this is a term we used earlier in Module 2, specifically Chapter 3. And so hopefully you can recall what that means. If you don't remember, let me remind you, reliability is the tendency for a measure to produce the same score over time. So we're really looking at consistency here. So I think I used this example previously, but if you step on a scale and it tells you you're 100 pounds, you step off, it tells you you're 100 pounds, you step off, you step on, it tells you you're 100 pounds, that's a reliable scale. Every time you step on, the score is staying the same. And it should, because nothing has really happened in between. Okay. And recall that reliability must be established before you can establish validity. That is, a measure must be reliable before it can be valid. But also recall that just because a measure is reliable does not make that valid. That scale I step on tells me I'm 100 pounds every time. That's a reliable scale. But if I really weigh 200 pounds, then that's a reliable scale, but it's reliably invalid, meaning it's reliably telling me information that doesn't represent the truth. And so it's important to make that distinction that reliability is sort of a prerequisite for construct validity, but it's not enough. You can't replace the two concepts. So what we'll do in the rest of these slides is talk about how we go about, or how researchers go about, establishing reliability when they create a measure. One of the more common ways to establish reliability is through a method we call test-retest reliability, and the method is pretty much in the title. What you do is you take an individual, and let's say you give them a self-report test. Maybe it's an IQ test, maybe it's an SAT, okay? And then sometime, usually close in time, you'll give them the same version again. Okay, we usually want this close in time because if you spend too much time between testing instances, things could potentially happen that might alter their score. And so the way test-retest reliability works, it works under an assumption that nothing has changed. So personality measures and IQ measures are thought to be consistent over time. And in these cases, we would still try to test close in time, but we wouldn't worry so much about it. And so the idea is, if you have me take a personality test and it says I am highly introverted, if the next day I take the same test, it should also tell me I'm highly introverted again. That would show test-retest reliability. You're getting the same pattern of scores on the same measure over time. Okay. Now it's important to point out that it doesn't have to be the exact same score. It's more important that it's the same rank order. So for instance, if I take the SAT and I get a 1300, I take the same test again the next day, I might get a 1360. Okay, that still might show test-retest reliability. The more important thing we want to look at is rank order, right? So if I'm 30th percentile with my score of 1300, when everyone takes the same test again, I still want to be 30th percentile. If I go from 30th percentile to 50th percentile, or if I go from 30th percentile to 10th percentile, I'm probably not demonstrating reliability there because my place in relative to other people taking the test has changed dramatically. So it's not about the exact same number so much as being in the relatively same percentile or portion of the distribution. Okay, so that is the most common kind of reliability that works really well with self-report measures, questionnaires, and those kinds of things. The next kind of reliability, called inter-rater reliability, is most relevant for observational research, where you have people behaving either in a lab or out in the world, and they're not just filling in circles on a piece of paper. And so what happens here is two or more, the more typically the better, raters or coders, sometimes they're called, would watch a particular behavior and they would write down what they see happening or how they're interpreting the behavior. And you can show inter-rater reliability when two separate individuals view the same behavior and identify it or categorize it or call it the same kind of thing. Okay, and so this is really important for any observational research study, because if you just use one person, we know that person's take would be inherently biased because that just happens when you're one person. So you do need multiple people here, and that's how you can show reliability with this kind of measure. If you think back to an example we talked about in chapter 3, we talked about, identifying aggression. So let's say we're watching a video of kids on a playground, and myself and two other people are watching the video, and every minute a timer goes off and we have to record what we see going on in the playground. And we have what we call an ethogram or a code book that lists out the sort of behaviors we could label it as. So we could label it as playing, we could label it as fighting, we could label it as talking, we could label it as sleeping, we could label it as running, right? We would come up with a whole list of labels. And the goal is, while us raters are not talking to one another, we're not interacting with each other, but we're watching the same video, we all write it down as the same thing. You would not get inter-rater reliability is if we all watch the same video and you call it running, I call it playing, and somebody else calls it fighting. Well, that's really bad, right? And if that's consistently happening minute after minute after minute, then we would not have inter-rater reliability. So the way to get inter-rater reliability when you're doing these kinds of things is actually to do a lot of training ahead of time. You use a lot of practice videos where you can talk to each other about what you're seeing. And in these practice videos, I can say, oh, I called that playing because the kids had a smile on their face, and even though they were running, they seemed to be interacting and talking about something. Whereas the other coder might say, oh, see, I just called it running because I didn't notice the smile and I didn't think smiling mattered for running, right? And so you do a lot of practice to get consistent on the codes. You will then do some practice runs on new videos once again. And once you get some criteria that is good, somewhere upwards of 80 to 85% inter-rater reliability, then you can go on and do the actual ones you're going to do the data analysis on. But usually there's a lot of practice beforehand. If you didn't do that practice, inter-rater reliability would be almost impossible to get. So that's a really important part. And when you're designing a study, you should know this so that if you had to use inter-rater reliability, that you know to plan your time accordingly, because it's not just something you can show up and do. It takes, in some cases, weeks and weeks of practice to get it right. Okay, and the last kind of reliability we can look at is something called internal reliability. And here we are returning to sort of self-report scales. One of the things which we'll talk about more in the next module when we deal with survey items or self-report scales is that there should be multiple questions asking about the same thing. That is, if I'm studying personality, let's say, and I am interested whether you're neurotic or not neurotic, I don't just want to ask one question that says, how much do you agree with the following statement? I feel neurotic. Neuroticism as a conceptual variable has a lot of different components. And so you want to ask about those individual components because they're all related to one another. And by asking about the individual components and possible examples of neuroticism, if I take the average of all of those scores, I have a better sense of what your true level of neuroticism is versus if I just asked one question, right? It's the same idea with just using one rater. If I just use one question, that question might be written in such a way that it biases the answer. And so we want to use different versions of the same thing. So to establish internal reliability, what you would do, or what the researcher would do, is you would take, let's say, the 10 questions on neuroticism, and you would split them into 2 groups of 5. Okay, so you randomly take 5 questions about neuroticism, put them in group A, take 5 other questions about neuroticism, put them in group B. You would calculate the average of group A, that score, and the average of group B and that score. And if those 2 scores were highly correlated, that would be showing internal reliability. That means the items within the scale themselves all are highly correlated with one another. That would be one way to show reliability. Okay. If we take the 5 questions, and I'm scoring a 5 on those 5 questions, and I take the second group and I'm scoring a 2 on those questions, that would not be really good internal reliability here, because my scores, which are all supposed to be about neuroticism, are quite different when I look at these 5 versus the other 5. So what we're hoping to show, if we're doing this kind of reliability analysis, is that when we split questions into groups about the same kinds of conceptual variables, that those answers are similar to one another and highly correlated with one another.